Welcome back, ladies and gentlemen, to another Murph Codes front-end web development tutorial, where we are currently making a game in JavaScript for the browser. Let's see. Last time we were at this, we did kind of a in-depth review of everything. Today, I'm just going to talk about how we got him to move and detect when he's colliding with something. I'm still not 100% satisfied with the movement. Not yet. I think what I want to do is I want to tone down the amount of gravity, or the amount of we'll try that. And then yeah, we'll give that a shot. See what that does. Um, let's see. We need to clear the cache because otherwise it might not reload all of our files here. That is so slow. That is not ideal. Yeah, no, we wanna go a little bit more than that. We'll probably be tinkering with these. That's a little quicker. Now you might notice we no longer slide through the walls. Can't remember if we handled that on stream or if that was part of my off stream stuff. We also kind of bounce off the walls if we run into them hard enough. Anyway, so our little green slime cube is contained inside of the maze. There is a possibility of glitching him through the wall, though. And also, if you get to midpoint here, there we go. See? We can glitch him through the wall. um, I still feel like it handles better than if we set hard limits, though. Because you have to be trying to glitch him through the wall. And this way, the same method that detects if he's going to run into, say, these here or these here, detects if he's running into these here. And since we're using the same tiles, essentially, it should be the same data. So we don't have to write an entire separate chunk of code just to detect if he's going too high, too far to the left, too far to the right, too far down. Because remember, our game scales with the size of the window. So we would have to factor that in on all of the math. This upper limit is not the same as this upper limit. And while we've done this math a couple of times, we would just end up having to do it again. Let's not put ourselves through that, okay? So we've got our uh, our key controls. We have our movement. I simplified this. Before I had it so that there was an amount of gravity that had to be overcome in order to start moving, but I made it so that initial movement would just make you overcome that gravity anyway. I took that out. We don't need that. We still have the gravity though. It just acts as uh, drag to the velocity here. And that gets applied every time we draw. I have tinkered with this number a little bit, and I found anything less than 1 kind of leads to some um, weird behavior with the sprite. He'll just kind of drift every once in a while in just some random direction for no reason, and I don't know why. I don't know why he does that. So I'm leaving it at 1. We're calling it good there. We're making it so that he only goes as many as 8. Although I think I can jump this up to 10. I don't think that's going to really cause a huge... I don't think that caused a huge amount of issues last time. No, it just means he can get going pretty good when he gets a steady run out in the open. Which is fine. We don't mind that. It takes him a little while to get to his top speed, which is okay. And with the shortness of a lot of the straightaways here, that's not terrible. Let's see here. I had some other funky math stuff that I had to do. Oh, was it here? Oh yeah. We had to tinker with the collision uh distance a little bit because what we're ending up doing here is we're creating uh corridors here. And like right here, see this wall? There's not a lot of space between these two. So it can be kind of hard to hit that if we're even just a little bit off. So I had to widen it a little bit because then there'd be places like this, which would be almost impossible to get into. And for that, I just did this bit here. What I'm doing is I'm taking some number, and it's actually a fraction. This would be 27/30ths. Multiplying that by the width of the actual sprite. What this does is this very minutely uh, opens up that corridor. Just a little bit. We don't want to go too far because if we get too far with it, we create gaps. I'm using the ice level. That's probably not the best one. Let's try to get something other than ice. Here we go. All right, so like you see this corner here. If I widen that, or if I use a fraction that's too wide, like if I went 20/30ths or something, I could make the gap between these two big enough that I could get wedged way down in here, which would make it actually easier to glitch through the wall. So we don't want to do that. We want to make sure we're using a pretty decent number, not too large of a number, but enough where we can still fairly easily maneuver into most things. Anyway, there's going to be a lot of fine tuning of the controls that you can do. Some of the stuff you can do will cause some very strange things to happen. Some of the stuff will cause a greater possibility of glitches. And it's entirely possible that the complexity of the way we're doing things might be why we're getting weird behavior and why we're introducing so many glitches. Um, you just have to be comfortable with the level of perfection, okay? Um, at some point you have to be like, okay, this is good enough, and then move on to the next thing. For me, we're at that point with the movement. We don't need to worry too much about that. But let me run you through how it works. Our hero starts at this particular location, has a vector x, a vector y. This is his movement, left and right, up and down. Gravity is just the default drag, and the vector cap is how fast he's able to go. This is kind of a governor on him. We could disable this entirely, or crank it up to 1,000,000 if we wanted to, and he would fly. Uh, don't worry about this part yet. We haven't gotten to this part yet. We will. Hopefully today. Hopefully that's what we're doing today. In the movement method of our Slime Hero class, here's how we're handling things. We pass the X and Y, which these are the X and Y. And what I'm doing here is I am unnecessarily, probably for the way this code works specifically, I'm taking whatever the X and Y that was passed in, and I am just making sure that it is an integer, a whole number of pixels, so that our little program isn't having to do complicated math. And we're adding that to whatever the existing vector is. This will allow it to compound momentum, you know? Um, as long as we're overcoming the draw loop of 60 times a second. Is that what we're at? 60 times a second? Yeah, 60 frames per second. That's how often we're having to draw our hero. That's how often this gets called. And if you come down here where we apply drag to our velocity, and all this does is it checks for various values of our x and y vectors. Because remember, negative vectors means it's moving in a certain direction. Positive means it's moving in a different direction. 0 is standing still. 0 is standing still. How do we apply gravity to something that can be both positive or negative? By narrowing it down to 0. So what we're doing is we're checking, is it less than 0? Add gravity. That'll make the negative number smaller. If it's greater than 0, subtract gravity. That will make the number smaller. And we do that for both x and y. And that's how we're applying our drag. We're just using it to bring the number closer to 0. That's all we're doing. What we want to do next, though, is this part right here. Because as you've seen, a little slime guy has been a very wooden kind of actor here. He does only have the one facial expression. He is essentially the Keanu Reeves of video game superheroes. And we want to take our little buddy to acting class. All right. So, what we need to do is we need to figure out what we're doing instead of 1-1. All right, because if we go back to this one, go up to draw slime, cell X, cell Y, that's our 1-1. That gets fed into our draw image, cell X, cell Y. All right, image is this thing. This is our 1-1. This is 0-0, this is 1-1. Which is why he's constantly got this look on his face. Even demonstrate that here. Ta-da! He's looking the other way. Now, as you recall, we have several different frames here. Now, I didn't put them in any real order here, so much as just what's going to be easiest to draw. Because I did this whole thing in paint.net. I was going to use GIMP, but for this kind of work, I felt like something simpler to use, and I felt paint.net was just simpler to use, so I just went with that. Now what we're gonna do is we're gonna have a series of different different animations here, okay? And we're gonna control it with arrays. These arrays are going to tell us which frames to cycle through. And we'll skip to the next frame, skip to the next frame, skip to the next frame as we move through the animation. When we have to do those, we have to populate these lists with the frames in the order that we want them. So, his initial movement is 1-1. And if he just stands there, I don't know, do we want him to occasionally look left, blink? Don't know yet. We can just leave it at 1-1 if we wanted to. But what is the other direction for our 1-1? 1, 2. Let's see. 0, 1, 2, 3, 4, and 5. So 1. Oh, wait, no, that's not 1, 2. Is it? I think that's this one. And I think we want this one. Yes. All right. So. Because, yeah, it goes X and then Y. So. What we should do is figure out our animations for moving in the various directions. We want... let's see. Let's kind of match this up with our up and down. Right? With our key controls, we have up, left, down, right. Okay, so if we're moving in an upward direction first, let's start with this guy right here. We're going over 1, 0, 0, 1, 2, 3, 4. So we're going to start at that. Go 1, 1, 1, 4. And then the... Did I do a larger upward, or did I just only do the 1? Yeah, no, that would be this one. So, again, 1, 0, 1, 2, 3, 4, 5, 6. Oh, my child's going crazy over there. Okay, so we start with this. Then we start moving upward. Then we really get moving upward. And then I think I just want it to kind of cycle between these two as he moves upward. You know what? I'm gonna take that. I'm gonna move that down here for a minute. I'll come back to this one. Don't worry. So this is our very basic upward motion. Now we do have two options we can use on this. Plus there's a blinking option. And we'll get into that in a bit. What I want to do though first is I want to set up so that we have some kind of animation. 1, 2, 3, 4, 5, 6. 6 is good. Now, going left. Two zero and 2 2. Then we need a down motion. Let's see here. We used this row for down. We'll go with this row for down. So 0, 1, 2, 3. Three, 5, 3, 7. Yeah. All right, and then to the right. What did we use last time? 2, 0, and 2, 2. We'll go with these two. That's 1, 1, 1, 3. All right. Now here, because we're already doing our check to see which direction we're moving in, this is also a good spot to check which sprite index we should be using. All right. So if we're moving up, that's y is less than 0 right here. Now, the way we're using this sprite index is a little weird. First one indicates which list we're using. The second one will indicate which element in the list. I hope that makes some kind of sense. Okay. Now, down would be 2, because it's 0, 1, 2. And left is less than 0. Less than 0. That's a 1. And then greater than 0 is 3. All right. So how do we handle the other number? Sprite animation. We want to do. So as long as the number stored at sprite index 1, which is the second number in our sprite index, is less than the animation sequence we're currently running, uh, which will be determined by the first number in the sprite index. Long as that animation hasn't reached its length, add 1. Actually, we might want to subtract, go 1 less than that. Right? We'll try it without, see if we run into any problems first. Else, which, this will trigger anytime this hits that length. What we're going to do, we're going to reset this back to 0. Now we only want this to run when there's movement. Like if we're standing still, we don't need it to happen. Let's see if this totally screws things up for us. Oh, wait. We haven't done any changes to our actual drawing of anything, have we? We haven't. This animation. All right, so how are we translating this? This is the part where my brain goes, Darr. Okay, so looking back at things, our up and down is determined by sprite index 0. So that'll be the first number. That'll tell us what cell we're on. And then this tells us which of the thingies we're doing, which of the coordinates, and it's x, y. Seriously, no idea if this is going to work or if I just totally screwed everything up. But let's try it. He disappeared. Okay, what did we lose? Uh, 77, 71. Okay. It didn't exactly work. We have nothing. No problems. Now we have problems. It's always the third key press. So the third time. Maybe that'll fix it. I don't know. I don't know if that'll fix it. Still have a problem down here, though. Ah, okay. There doesn't seem to be any errors, but doesn't mean there shouldn't be. Yep, see, it still explodes by the third frame. It just does not like that. And he ain't coming back either. Okay. We can go quite deep on these things, so it's not like we're doing that part wrong. Am I spelling something wrong? Is that what's going on here? try just doing a hard 6. After all, that is what we're getting at here, because we've only got 6 cells to an animation currently. Same prop. Hmm. Oh, so annoying, because I don't know why it's not working. Hmm. Hmm. I'm probably overcomplicating the prop. It's probably what I'm doing. I don't know if this is going to improve that or make this more complicated. Uh, we'll see. We will just have to see. Uh, Up, left, right. Okay. All right, so the way this should work, this is the key for our dictionary. This will be the up, down, left, or right direction that our character is moving in. This will be a value of 1 through 6, determining which frame we're drawing from. And then this will be the x coordinate, and this will be the y coordinate. If I've translated this correctly, I have no idea. All right, let's see what we've got here. Save that. Let's clear our cache. Settings. Refresh. We have no hero. We have no hero. Okay, that doesn't work at all now. We have officially broken it. Undefined at 0. Okay, he's back. What are we getting for values here? Settings. Clear. Okay, that should actually be right. Left. Up. Down. Okay, so we have a little bit of a mix-up here. X left and zeros, left. Right. Up. Down. Okay. Okay. Perfect. So far, so good. I'm using the right name, all right? Okay, animation. Undefined. What? Why? Why is it undefined? Oh, I probably formatted this thing wrong, didn't I? Yes, I did. It's supposed to be that. Okay. Now we're delivering an array, which is perfect. That's what we want, I think. It's an array of 2. And actually, it's an array of 6, so we need whatever element from there first, which should be sprite index 1. So far, so good. So far, so good. Now, here comes the fun part. Now, this should just deliver those 2 numbers. Okay. Feels like we took an awful long route to get here. All right. And that's probably really hard to see. So let's size that up a bit. It's still not working quite right, is it? Because left and right are using pretty much identical uh things. Let's take a look here. I'm pretty sure the actual animation part itself is working. But our sequences are not. All right. Also, okay, let's take a look here. Down is not down. Up is almost up. Down is right. Why is down right? What right is also left. Left is way left. But he's technically animated now. It took a long way to get here, but he's technically animated now. So, let's take a look at our stuff here. You see 3537. Ah. So, up seems to be okay. And that's a 1416. 0, 1, 1, 2, 3, 4, 5, 6. That makes sense. Down does not make much sense. It's a 1113. No. No. Down should be 0, 1, 2, 3, 4, 5, 7. Down should be 5, 7. 5, 7. The up and down seem to work a little better now. Okay. Left and right. So if we're going left, 1012. And right. Three one 3 3. The animation's a little more natural. Although the up I'm not a fan of. Let's change the up. What do I have for up? 1416. Let's go 3436. And you don't get much of the jiggle of the slime cube. So we have a way to change that as well. Basically, add more cells. Now, we could slow down also how quickly it kicks over, but we would have to have a number that keeps building and building and building, then do floor math, and it's just easier to add more cells. Because at this point, it's just a 2-digit coordinate thing. And if we have the same cell repeat enough times, that cell is frozen. So, yep, missed a character there. Proper spacing so that we know if we're doing this right. Okay, and lastly, And the result should be more visible animation. Let me get you something that's not Ice World. There we go. It's better. It's more of an animation than it previously was. It's not great, I'll give you that. It's not great, but it's better. It's much better. Now, you might be thinking, well, what about the blinking that you did? Because got whole animation cells where he's blinking. His eyes are closed, clearly. How do we make that a thing? Oh, we also forgot to extend this out. Because now our sequences are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 long. So let's go down here. Easier to see when he's not zipping quite so fast. So maybe we turn down the velocity here. Whoop. I don't want him to be too sluggish. And this is probably too slow. But he does have a better animation when he's going a little slower. Just a little bit. Got that little jiggle to his walk. Now, like I said, we'll probably have to tinker with the numbers a bit. Now, there are finer controls we can add to this. Because looking at our little slime cube thing, we have some where he's looking left, some where he's looking right. And it's literally that's the difference between even and odd there. Somewhere he's heading right, somewhere he's heading left. Then there's ones where he's blinking. In either direction. We want to try to use as many of these cells as we can to try to give our hero personality. And it is this animation dictionary where we will do that. So we have a very simple up, left, right, and down. That's why I got that wrong. That's supposed to be down, right. Silly me. Okay. I was wondering how I could have possibly screwed that up before. Because I got the order wrong here. Which is why I had to redo the order there. Oh, gosh. Okay. Hmm. As far as like how we animate the rest of his expression, I'm thinking we're probably just going to randomize the blinking. We'll probably have to tinker with that until we find a decent a decent rate of blinking, but it's going to be random. So like occasionally he'll blink a couple times real quick, and then he won't blink for a while, or he'll stare for a while and then just randomly he'll blink. Uh, but I'm going to show you how we're going to handle that in a moment. Actually, we might, because we're almost at 2 hours here. We might save that for next time. And besides, I'm not entirely certain just yet how I plan to do that. Um, we're going to change the key of our dictionary, though, and we're going to extend this so that there's more. We're basically going to try to use every possible frame of this sprite sheet in some way. Most of them. I'm still not sure that we're ever going to use these two rows here. I just kind of threw them in as maybes. But we should be able to use just about every other row. And how we're going to set this up is instead of just up, left, right, down, it's going to be move up, look left, move up, look right, move left, look left, move left, look right, that kind of thing. And we're going to construct our key which, if you remember right, that's this first sprite index from a string. All right. And that string is going to be generated from a couple of factors. One, the blinking is going to be random. Two, the looking left, looking right. I want to be looking at the closest bad guy. So when we start adding bad guys, he's going to look in the direction of the nearest bad guy. His eyes will change left or right depending upon where the nearest bad guy is. And then we're going to string that together to form the key for this animation. Okay? Blink will be random. Looking left, looking right will be based on where the nearest enemy is. We'll probably have to wait before we have full control over that part till we get enemies inserted into the maze. Just because otherwise, what are we testing this on? I mean, I guess we could do, having him look at the nearest wall, if there's a wall. But I would prefer to have our hero be able to at least give the appearance that he recognizes uh, danger. And so we're going to do that. We're going to utilize, because as you can see here, we have a look left, look right, look left, look right, look left, look right, look left, look right, look left, right, left, right, left, right, left, right. And it's basically an even odd. Left, right, left, right, left, right, left, right, left, right, left, right. As long as we're in the first half. The second half is where we get into our blink. And then it's just the odd ones. Or I guess that would be the even ones because we start at 0. 1, 2. Yep. Yeah, it'd be the even ones. So, I'm going to probably work on that between now and next time. And then next time, I'll show you the implementation of that so that you have a better idea of how we're doing the full animation for our hero. Um, I may also slow down the animation a bit more by just pumping in more frames. Because we can extend that out as far as we need to. Because when we do a slow walk, it's obvious. When we go faster, it's less obvious. And I'd like it to at least be a little more visible when he's doing his quick darting left and right kind of motion. And we can slow it down by inserting more frames. The way that we just did by making it so that the same frame repeats 3 times if we extend it out to repeat 5 times or 6 times or whatever. We make that frame visible for longer. Because remember, with the way we have it set up now, as long as there's a velocity value, the frame will change. If the subsequent frames are the same, to our eye, it won't appear any different. It's not the most elegant way of doing it, but it works. We could have probably put in some kind of control that handled that a little bit better, but I feel like for our purposes today, this is good enough. This is good enough. Um, Also, I want to get this to work properly as well. Because instead of using just the number 17, what we should be able to do is that. I think. And then it shouldn't matter what what length we eventually have to make these sequences here. Like we can just extend it as far as we need to. It should just work. Yep. That seems to be working now. Boy, it sure is in love with the ice cave today. But our hero's a little more animated, which is what we were going for. Gives him a little more personality, a little more depth. He's not just a sliding tile on a screen anymore. He is now a gelatinous cube that wiggles across the screen. Uh, I'm going to tinker, like I said, with the number of animation cells till we get to a point where he could be at full sprint, but we're still seeing the undulations of his gelatinous form moving across the screen. Uh, Hopefully it'll look better. Hopefully. Um, I want to say next time we'll try adding in bad guys, but I don't know if we're going to get that far by that time. I'd like to. Especially since it gives us another element for our hero character to interact with. Because, like I said, I want him to be able to look in the direction of the nearest bad guy. Give us a sense that he's aware of the danger in the maze with him. Um, we do, however, have to add also an objective. I don't know if we're going to give him an ability to defeat the bad guys that he encounters, or if it's just going to be um, an obstacle for him to avoid. We'll see. And hopefully it'll be good when we're done. Um, but right now, I need to go make some lunch. So this is as good as any place to call it. Thanks for joining me. Join us next time where we take this even further. Really complicate the animation sequences. Hopefully throw in some bad guys for him to interact with. See how all that goes. Um, if you're wondering what's up with the video game playing, we will be back to that on Friday. Hopefully, we'll be playing some more Legend of Zelda: Link's Awakening, trying to recreate the original dungeons from the original Nintendo uh, Legend of Zelda, the very first one. Um, Join us for that. That's going to be a good time. I mean, it's not going to be an easy, one-to-one recreation. We're going to have to kind of give our own interpretation of those dungeons, but we'll see what we can do. Um, Again, thanks for watching. Have yourselves a great one.